Okay, it's chapter 2. So the first chapter we focused on the scientific method, which is a process that scientists use to answer questions. Chapter 2 is now going to focus on the tools that we use in that process to answer questions. So it doesn't matter what type of scientist you are, every scientist has different types of tools that they use. So our different sections that we have in the chapter, the first one here is going to be measurement. Then we're going to talk about time and temperature specifically, and then about systems and variables, and then we're going to wrap it up with graphs. So what is a measurement? A measurement is actually two things. So think of any measurement that you may be familiar with. Maybe how many gallons of gas you put in your car, or gallons of milk, or maybe you go buy some fabric at a store. But what measurements are is they are a number that include a unit. So when I talked about measuring gas, that's going to be in gallons. When we're talking about milk, also in gallons. If you're in Canada, that would be in liters, right? If you're measuring fabric, then that's going to be in yards. So it's very important to note that measurements always include a number plus a unit. So a unit is a specific quantity that is counted to make a measurement. So I just gave you a couple of units. I said gallons, I said yards, but there's so many different units depending upon what type of measuring you are doing. The picture in your book here has centimeters, and then it also has, we may be more familiar with a yardstick. Now, got to remember in science, we love the metric system. We're going to talk about that in a little bit here, but metric system uses centimeters. So 100 centimeters. Centimeters is a unit. So a basketball player might say, I'm tall, I'm almost too high. Well, to what? Are you talking about 2 inches, 2 centimeters? What does that mean? So the basketball player is not tall if his height is almost 2 feet, right? So the picture of the dog there, only 2 feet, but now look at 2 meters. So you can start to see the importance of having accurate units with measurements. So if the basketball player is 2 meters tall, this is a height of about 6 feet 6 inches, much different than 2 feet. So at one point in time, way, way long ago, the English system of measurement was used in many places. Included dozens of units even for just weight. So your book shows you these pictures here. So they use carats, which we may be familiar with because if you buy jewels, they're measured in carats. They use grains of medicine. They use something called a nail keg. So there was lots of different measurements used just even for weight. They started to notice a few things. They were hard to compare to each other, and there was also, even earlier on than that, some inconsistencies with measurement. So if you're looking at even the foot, where the foot comes from, think of that. The foot, doesn't that sound like something that's on your body? Yeah, because the foot used to come from the measurement of the king's foot at the time. Isn't that a problem? Now, first of all, not only was a lifespan not very long back then, if you have different kings, you're going to have different measurements for what a foot is. So they needed to come up with a more consistent system of measurement than what they were using. And this is it. So in the 1800s, they developed what we now know as the metric system. So a new system of measurement was made in Europe and Great Britain, the metric system. And I know sometimes we hear the metric system and we're like, metric system. Metric system is wonderful. Once we get used to it, you start to see how much easier it is than the system that we use. And why do we use it in science? Because you got to remember, science is a global language. So scientists don't just stay within their countries when they perform the scientific method to answer questions. That data is shared with scientists throughout the world. Everywhere in the world uses the metric system except the United States, and I believe there's a couple of countries hanging on to it, but that's it. So think of that. Everywhere else uses the metric system. So it makes sense that scientists use the metric system. Now, why is it so easy? The fact that I have on the screen here is really why. All units are multiples of 10. Every unit is a multiple of 10. When you think about our measurements, let's just go with the foot again, 12 inches in a foot, right? How many feet are in a mile? 5,280 feet are in a mile. Weird numbers to remember, right? Not in the metric system. So in the metric system, everything is based on multiples of 10. And you also start to see another cool thing is you see a relationship between liquid and linear measurements. So the book shows you the picture on the bottom here. If I have a cubic foot, so imagine a box that was 1 foot on each side, it holds 7.48 gallons of liquid. Once again, weird number to remember. If I have a box that's exactly 10 centimeters on every side, it holds 1 liter of liquid. Now, if I go even smaller, so if I have a box that's 1 centimeter on every side, just a little tiny cube, it holds 1 milliliter of liquid. Once again, easy numbers to remember. So metric system based on the number 10. Just to kind of go through the basic measurements that we use. So in the metric system, every type of measurement has what we call a standard and a basic unit. Now the difference between that is a standard unit is essentially the measurement that's used the most. I'll say that again. The standard unit is the one that is used the most. The base unit or basic unit is the one by which all measurements are measured on. So standard, most used, basic, what it's based on. So for length in the metric system, we use the meter. Long time ago in 1791, they actually based it on the distance from the North Pole to the equator. It was 1/10 millionth of that distance. Now there's a problem with that. I don't know if you knew this, but the Earth actually changes shape a little bit. So you're now taking a measurement that changes a little bit once again, just like that king's foot. Not a good idea. So nowadays they actually use the speed of light through a vacuum. So very, very easy to remember. So prefixes are added to the names of basic units in the SI system. So the other cool thing about the metric system, it's not like we have to memorize all these new names. We just take a base unit and we change the prefix to it. Here's the most commonly used metric prefixes and their abbreviation. And they can be applied to anything. There are more, there are less. I just kind of picked the ones in the middle here. So for example, a kilo, abbreviated K, means 1,000. So you guys should be putting this in the chart here. So what that means is if you have a kilometer, you have 1,000 meters. A hecto, H, means 100. So if you have a hectometer, you have 100 meters. Now deca can be spelled either way depending upon what root word you're coming off of, but it's abbreviated DA. So a decameter, DAM, is 10 meters. Now getting smaller, if I have a decimeter, 1/10 of a meter. If I have a centimeter, I have 1/100th of a meter. So if I have 1 centimeter, think about that, 1 centimeter, if you added up 100 centimeters, you'd have a meter. Millimeter, 1,000th of a millimeter. So those are our most commonly used ones, and they apply to everything in our metric system. And I'm going to show you that later on, kind of what that means. But those really are ones that you can kind of commit to memory, and you should have committed to memory. So your book talks a little bit about measuring length. If you need to measure the thickness of a plant stem, you would probably use millimeters because it's small. So you got to think about, we have all these units because we can use them based on what we're measuring. If we were measuring from here to Grand Rapids, probably not a good idea to use millimeters, right? Because our number would be really big. We would probably use kilometers because that's a bigger unit. So we adjust our units based on what we need. It's really important when you guys are measuring with the ruler, you always estimate one beyond with that ruler. So if I'm looking at here on the top part, because that's my metric part on the top, you'll notice that it's in an increment of 10, right? So if I look between 4 and 5 here, it's an increment between, I've got 10 in there. So this would be 1 centimeter. So on the very top, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters. So if I have something just a little bit more than that, let's say it's on the first line after 5, 5.1 centimeters. If it's 2 lines after, 5.2 centimeters. Volume is how much space something occupies or contains. SI unit, so that's the abbreviated way of saying the standard unit. Remember I said the standard unit is the one most commonly used. So the standard unit for volume in the metric system is the liter. So that's why I said earlier, when you go to Canada, if you buy gas, you're buying it in the liter. You're not buying it in gallons. So standard unit is the liter. And most of us are kind of familiar with liters. We are familiar with like a 2 liter. Think of if you buy a 2 liter pop bottle, we're familiar with that at the store. So now just divide that in half and that would be a liter. Something that we should have committed to memory here, because we use it so much, is if you were asked to ever calculate the volume of a rectangular prism, so that would either be a cube or a box, think of it that way, all I have to do is take length times width times height. So volume of a rectangular prism, length times width times height. So if I wanted to find the volume of this cube here, 10 times 10 times 10, and make sure if you're multiplying those units together, cm, cm times cm, the answer is in cm cubed, just like that you see on the bottom there. So if an object is a solid cube or rectangle, you can measure its length, width, and height in those SI units, and you just multiply them together. Important relationship on the bottom here. So remember I said to you earlier, if I had this cube that was exactly 1 centimeter on each side, it would hold 1 milliliter. So those units are what we would call synonymous with each other. They mean the same thing. So if I have 1 milliliter, it means the same thing as 1 cubic centimeter. Or the one that you see on the right side, 1 cc. You may be familiar with that because they use that in medical terms a lot. They'll talk about I need 10 cc's of medicine, and they're really saying 10 milliliters or 10 cubic centimeters. So we can find volume a few different ways. So if you have a solid object and it's a perfect geometric shape, you can do like I said earlier with the length times width times height. However, if you're finding the volume of a liquid, we'd either pour it into a beaker or a graduated cylinder, more often the graduated cylinder because they are more accurate and they are measured for us in class most often in milliliters. And you'll notice it's often lowercase m, uppercase L, so we don't confuse that L with 1. So milliliters, lowercase m, uppercase L. When we measure using a graduated cylinder, that water is attracted to the glass, so it'll climb up the side of the container. So it's really important to remember you are measuring the bottom part of that graduated cylinder, or the bottom part of the water that's called the meniscus. So measure the bottom part. So if I were measuring this, it looks like this is probably 51, 52, so 52.7 milliliters, I would probably say here. We can start measuring really large volumes and think about, once again, appropriate units, cubic meters, cubic kilometers. We can have bigger measurements there. Matter is anything that has mass and takes up space. And so we can actually measure how much matter is in an object by measuring its mass. So we can measure length, we can measure, which is remember how long something is, we can measure volume, which we just said was how much space something occupies or contains, and then finally we have mass. So how much matter is in an object. So I can take and actually figure out how much matter is inside of a paperclip. The measurements that we use in the metric system to measure mass are grams and kilograms. Now, notice on my slide here, the standard unit of mass in the metric system, or SI system, just another abbreviated way. It actually stands for the French version, Système International. That's where the SI comes from. The kilogram, standard unit of mass in the metric system. Why is that? Because a gram is just so light. So the gram is the basic unit of mass in the SI system, so we use it to measure everything for mass. It's just too light. 1 gram is about the weight of a paper clip. So now imagine figuring out what your mass is. How many paper clips would you be? A lot. So in order to keep us to numbers that make sense, we use kilograms, abbreviated kg. And we use balances or scales to measure mass. So we like to use these guys, triple beam balances, and we'll be practicing these in class, but you'll see there's the 3 beams on there. That would be where the triple beam comes from. Mass and weights are not the same thing. So mass is how much matter you have inside you. Weight has to do with gravity. So on Earth, 15 apples weighs about 5 pounds. On Mars, if you took those same 15 apples and you put them on a scale, they would weigh only 2 pounds. And that's because Mars has less gravity. It has less pulling down on it. Same thing if we went to the moon, those apples would not weigh the same amount. That's why if you've ever seen a video of astronauts on the moon, it appears like they're kind of bouncing around a little bit. They don't weigh as much. There's not as much gravity on the moon. So weight is dependent upon gravity, whereas mass is not. If you weighed those apples and they were 10 kilograms on Earth and you go to the moon, they're going to be 10 kilograms. How much mass is inside them, that's not going to change. Same thing with you. You go to the moon, your weight's going to change, but your mass is not. So weight is a measure of the force of gravity on an object, whereas mass is not. So weight has to do with gravity. Weight has to do with gravity. Okay, so that's kind of an introductory course. I just want to come back to this slide here for a second. So now I've given you these other measurements. So we talked about meters and I went through all of these, but now think about the other measurements we just set. So we talked about grams and measuring mass. I can have a kilogram. That would be 1,000 grams. I can have a centigram, 1,000th of a gram. We can use this for liters. I can have a deciliter, which is 1/10 of a liter. A kiloliter is 1,000 liters. So see how nice that is with the metric system? I can take these prefixes and they apply to any of my base units in the metric system. Kilogram, kiloliter, kilometer. Doesn't matter what it is, it's 1,000 of that. So that's a cool thing about the metric system, is it's based on the number 10 and we can use these prefixes for anything in the metric system.